Alright, so we're going to be doing 1.3 Properties of Exponents, and we're going to simplify this expression. So this is one of those classic power to a power problems. So one thing that I can do with this type of problem is just write it out. Since the exponent here is only 3, I can write what's in the parentheses 3 times. So negative 2 x squared y cubed times negative 2 x squared y cubed times negative 2 x squared y cubed. Now, if this exponent was like, instead of 3, it was 30, it'd be kind of silly to write this out 30 times. But since it's only 3, we can just write it out the 3 times and then multiply through. So I have negative 2 times negative 2 times negative 2. Well, 3 negatives is actually a negative because a negative is a positive, and that positive number times a negative makes a negative. So 2, 2, 2. So these negative 2's make negative 8. All right, we have 2 x's, 2 x's, and 2 x's. So we have 2, 4, 6 x's total. And I have 3 y's, and 3 y's, and 3 y's. So that's 3, 6, 9 y's. So y to the 9 right there. Okay, so one other way to do this, which is probably a little bit faster, is to use the power to the power rule, which says we look at the exponent for each of these individual pieces and multiply by the exponent outside. Power raised to a power, we multiply. Same base and we're multiplying, we add. Okay, so just to clarify, x squared and x squared and x squared, those all have a base of x. And so I add the exponents 2, 4, 6. That's how I get x to the 6th. Okay, so just to clarify here, if I did it the quick way, I'd take this 3 and multiply by the power of 1 here. So that'd be negative 2 raised to the 3. And then I'd take that 3 and multiply by the 2 here. So it'd be x, and then 2 times 3 is x to the 6th. And then I have my y. 3 times 3 gives me my 9. And so when I multiply this through, I get this answer right here. Okay? So let's try out another problem. And we're going to have z to the 0, w to the negative 1, y to the 2, close the bracket, raised to the negative 4 power, divided by 4x to the y. And to make this a little bit more interesting, where we actually have to use this rule, let's change that negative 4 to a negative 40. Okay, so we're getting a little crazy here. Now, power to a power, remember what we do? We multiply each piece in here. Luckily, that first one, 40 times 0, gets me 0. So that's still z to the 0. Okay, negative 40 times negative 1 gets me positive 40. So that's w to the positive 40. And then negative 40 times positive 2 is negative 80. So that's y to the negative 80. Now in the denominator, we have 4xy. Okay. Now what we've got to do, we've got to take care of the negative exponents. We want them to all be positive. Well, that first one here, z to the 0, anything to the 0 power is going to be 1 unless that base is 0. And if it's 0 to the 0, 0 to the 0 is undefined. Okay, so we're going to assume that our variables are non-zero. All right, so anytime I have a 0 power here, I'm just going to assume that's going to go to a 1. So that is going to reduce to 1. Okay, w to the 40, that's good. It's already positive. Now this y to the negative 80, that's giving us a trouble. So I'm going to flip that down, do the reciprocal, and it comes into the denominator. and I have y to the 80 down low. Now this 4 here has a 1 for my exponent, so we're good here. And then both of these have 1, so it's okay to have this. All right, you may be jumping at the gun right now. Oh yeah, Mr. Clark, we can simplify this up. Sure can. What can we do here? We can actually combine this y and that y to the 80 gives me, well, same base, and we're multiplying, we add the exponents, okay? So in the numerator, I have 1 times w to the 40, so that's just w to the 40, divided by 4, and then I have an x, and I have how many y's? 1, and then 80 of them makes 81y. All right, guys.